Okay, guys, Jerry again here. I think this is lecture 9. I could no, is it? Could be lecture. Is it lecture 9? Time's flying when you're having fun, except the fun stops here really today. Now, today I'm going to do two things, or well, I'm going to do one thing definitely, and maybe if we have time, we'll do a second thing. The first thing, folks, is just dreadful. It's just the thing I hate doing this, and the reason why I'm doing it is because you might see this elsewhere because solving simultaneous equations is so important. Loads of different methods have been developed, including this one, which is called Gaussian elimination. And Gaussian elimination is just a piece of crap, basically. But it's in the book, and you will probably see it elsewhere, and you probably will wonder, well, why didn't Joey do this with us? I'm doing it now. Okay, so this is something that I'm doing, but I don't want to do. You know what it's like, folks. In my own personal life, it's like someone when you're married, your partner, wife telling you to put up shelves, you don't want to put up the shelves. You want to sit on your fat arse reading the paper. But you somehow you have to do this, and you think as an adult, why am I doing this? I don't want to do this, but you do it anyway. This is the mathematical equivalent of having to put up shelves for your wife stroke partner. All right, that's what it is. It has to be done. You think it's nonsense, but you do it anyway just for, I don't know, completeness or something. You feel that you have to do something crappy in order to do something better. Now, the mathematical equivalent of sitting on your arse reading the paper is what we're going to be doing, hopefully at the end of this lecture, but definitely in the next lecture. And it involves a little bit of something called machine learning. Oh my God, it's just so much better than this nonsense. Okay, let me show you what this is. All right, every step of this is embarrassing. There's nothing good about this, but I'm going to do it anyway. So the first thing you do, folks, when you're doing Gaussian elimination is you get what's called the augmented matrix. Okay, and the augmented matrix is the matrix of all the numbers that are appearing in your system of equations. So the first thing you do is you get what's called an augmented matrix. So the augmented matrix in this case, guys, is 2, 3, 1, 1, 1, 3. Okay, so the augmented matrix is matrix of the coefficients of x and y and the right-hand side put together. Now this is a 3 here. Sorry, guys, it's just so bad. Okay, so that's what you get. Now, the problem with this, even from the get-go, is it's not a square matrix anymore. It's not a vector. It's a stupid 2 by 3. It's just not symmetrical. It's just even the matrix that you start out with is not very nice. And in this game here, folks, you don't put brackets around the matrix either. So it's not really a matrix, because remember we said that it's a rectangular collection of numbers. And usually, almost always, when you're dealing with a rectangular collection of numbers and you want to emphasize the fact that it's a matrix, you put square brackets around it. Now, you don't need to, but everybody does. But in this stupid system here, in this stupid method, we don't even do that. Okay, so the first thing you do is you get what's called the augmented matrix. You write down the numbers appearing in your systems of simultaneous equations. Okay, let's call the first row R1 and the second row R2. Okay. Again, that's not part of your augmented matrix. That's what we're going to call the first row 2, 3, 1, R1, and 1, 1, 3. We're going to call that R2. All right. Now it goes from bad to worse here, folks. The next thing you do then is you draw a step. Okay, so this is what you do. So let me just draw the step here. The step for 2 by 2 matrix is this, the step for a system of 2 equations and 2 unknowns is what you see there. So you start off with up in the top left, and you go across to the first number, you come down and you go across. That's it. Now, the method, this Gaussian elimination method, what you do is you're going to use the top row here in order to get zeros here, a 0 here underneath the step, by using what are called row operations. And row operations are adding and subtracting multiples of one row to another row. So row operation is adding, subtracting multiples of one row to another. Okay, so that's what a row operation is. Now in this case, guys, the gain here is you want to get a 0 here. All right, and that's the gain by using what are called row operations. Now you would see here, guys, that if I multiply the second row R2, so what I want to do now is I want to replace R2, the old R2, by a new R2, such that I get zeros here. I get a 0 here. And how do I get a 0 here? By using row operations. So what I'm going to do here, hopefully you see this, I'm going to replace R2 by, if you see here, if I multiply the second row here by 2, and I subtract R1, so if I multiply this row here by 2, and from the result, subtract R1, I'm going to get a 0 here, because 2 by 2 is 2 by 1 is 2, and 2 minus 2 is 0. So, but there are multiple ways of doing this. There's an infinity ways of doing this usually, but this is just one way of doing this. So I see here that if I multiply the second row by 2, and from that then subtract R1, I'm going to get a 0 here, which is what I want. So the way I do it, folks, so if you do that here, then what you're going to get, you write down 2, 3, 1. You draw your stupid step. Now, let's multiply 2 by 2. No, let's multiply 1 by 2, and I'm going to get 2, and minus 2 here, I'm going to get 0. If I multiply this one by 2, because I'm multiplying, remembering now what I'm doing is I'm multiplying the second row by 2, each element of the second row by 2. So 2 by 1 is 2, and then minus 3, I'm going to get minus 1 here. And finally then, folks, I'm going to multiply the 3 by 2 here, so which is 6, and subtract 1 from it, and I'm going to get 5 here. The stopping criterion for Gaussian elimination is if you get a 0 underneath all the steps. And now I've got a 0. There's only one step here. There's only one position where I have a step value below the step, which is 0. So now I stop. And then what you do is you use back substitution. So here's step 3. Once I have a 0 here, I rewrite the last row as, because this is the y column, I write this as minus y is equal to 5. Because, okay, so where does this come from? Well, when you do the back substitution, then you substitute in the first entry here corresponds to the x, the second entry corresponds to the y, and the third entry corresponds to the right-hand side. So now what I'm doing is I'm using that. So remember now that the second column corresponds to your y, so you must multiply the minus 1 by y to get minus y, and that must be equal to 5 because 5 is on the right-hand side, so you get y is equal to minus 5. And then what you do is you go back to the first row here, and you get 2x plus 3, and minus 5 here is equal to 1. So then you get x is equal to 16. Now you get 2x is equal to 16. So you get x equal, and then you get x equal to 8. Deep sigh, folks. And that's what you do. That's how you use Gaussian elimination to solve 2 equations in 2 unknowns. So there's nothing about this that's elegant or anyway sophisticated. What I find very kind of disturbing is that disturbing. There's a lot of things that are more disturbing than this in the world at the moment, as we all know. But this is one thing that I find kind of annoying, is that this is called Gaussian elimination. And Gauss was a very famous German he was a German mathematician, and he is now very famous. He was such a smart man, like he was one of the smartest people who's ever lived. And I don't think he came up with this. I think somebody else came up with this and then called it Gaussian elimination in order to sell it. Because if you have Gauss's name attached to anything, it sells in mathematics. But this, I can't believe Gauss came up with this. Compared to what else he did, there's just no way he did this. Everybody is embarrassed by this. All right, so let me just make it more embarrassing even by showing you how to use Gaussian elimination to solve a 3x3 system. So you've got 3 equations and 3 unknowns. Now I'm going to use the example in the book. So here it is, x minus 4y minus 2z is equal to 21. 2x plus y plus 2z is equal to 3. And finally, then you get 3x plus 2y minus z is equal to minus 2. Now, let me just check that that's what it's in the book. Minus 2z is equal to 21. 2x plus y plus 2z is equal to 3. And 3x plus 2y minus z is equal to minus 2. Fine. So the first thing you do, guys, is you get your augmented matrix, which in this case is 1, minus 4, minus 2, and 21. And you get 2, 1, 2, and 3. And you get 3, 2, minus 1, and minus 2. Now, if you want to put square brackets around that, you knock yourselves out, go on and do it. But usually people don't. In this case, because you've got 3 equations and 3 unknowns, your step is a little bit more involved. So here's your step in this case. Now, boys and girls, what we're going to do now is we want to get zeros underneath the step. So we want to get a 0 here, a 0 here, and a 0 here. Now, to get zeros in this column, we're going to use the first row, multiples of the first row. Okay, so that's the very first thing you do. So here's step 2. So we want to get a 0 here and a 0 here. So this is R1, this is R2, and this is R3. Now, hopefully it's clear that if I multiply the first row by 2, and then subtract it from R2, I'm going to get 0 here. So if I replace R2 by R2 minus 2R1. So that's what I'm going to do first. So you leave the first row as it is. So I can do it over here just for space. Now, so multiply the top one by minus 2 and add it to here, and I get 0. Multiply the top one by minus 2. So minus 2 by minus 4 is plus 8. And then plus 1 here, I'm going to get 9. Because I'm just adding minus 2R1 to R2. Minus 2 by minus 2 gives me 4. And 4 plus 2 gives me 6. So that gives me 6 here. And the last one then is, I'm going to multiply this by minus 2. So that's minus 42 plus 3 is minus 39. So that gives me my new second row. So now what you look at, you see here, oh, look, there's a 0 here, which is what you want in the step, which is beautiful. It's not beautiful. There's nothing beautiful about this. But that's the first thing you do. So I got a 0 here. And how do I get a 0 here? By using a multiple of the first row to get a 0 here. Now, the next thing I'm going to do then, I need to do the same thing for R3. I need to get a 0 here. And you'll see here now, guys, if I multiply the first row by minus 3 in this case, and add it to R3, I'm going to get a 0 here. So I'm going to, if I multiply the minus 4 by minus 3, I'm going to get plus 12. Plus 12 plus 2 is 14 here. And then minus 3 by minus 2 gives me plus 6. Plus 6 minus 2 is 5 here. And I'm going to multiply the first one there by minus 3. So that's minus 63 minus 2, which is minus 65. And so now, look, if I do my stupid step thing, I have zeros here. Beautiful. And how did I get the zeros there? By adding multiples of the first row to R2 and R3. Okay, so that's the first thing you do. Guys, if you excuse me a second now, I'm going to kind of peer over here and make sure that this thing is still recording. Because we had difficulties last time. All right, seems to be okay. All right. Now, boys and girls, that's step 2. I've got zeros in the first column underneath the step. Now, guys, I will need to do the same thing. The last step then, I need to replace the 14 by a 0 using multiples of this row now. Okay, so to get zeros in the first column, I use multiples of the first row. To get a 0 in the second column, I'm going to use multiples of the second row. So you will see here now, this is not obvious. And can I come up here and do it up here? Because it just makes sense because I have the numbers in front of me. If I multiply the first one here, the first row here by, this is going to get horrendous. Because basically I want to get a 0 here. So if I multiply the first row here, so if I replace R3 by R3 minus, if I multiply the second row here by 14 over 9 R2, I'm going to get a 0 here. And where does the 14 over 9 come from? This is 14, this is 9. So if I multiply the first row here by 14 over 9 and subtract it from here, I'm going to get 0. I know this is just daft, but let's go on. So the first row stays the same. The second row stays the same now because I'm looking at the third row here. Now the last one then is 0. So I'm multiplying the first row, the second row here by 14 over 9. 14 over 9 by 0 gives me 0. And if I add to 0, I get 0. So that's where that 0 comes from. The 14 over 9 here, minus that gives me minus 14. And minus 14 plus 14 gives me 0 here. Now, in this case, folks, I'm going to multiply this one here by minus 14 over 9. So this entry here is minus 14 over 9 by 6, because I've multiplied the first row, or I'm multiplying R2 by 14 over 9, or minus 14 over 9. And to that, then, I'm going to add 5. So that's a 5 there. Sorry. When I do that, folks, what do I get when I do that? That is a good question. I'm not sure what I get here, but that's what you get. And finally here, guys, what I get here is I multiply the first row here by minus 14 over 9. So it's minus 14 over 9 by minus 35. And then add R3, and R3 in this case is minus 65. So that's what I get. So there's nothing nice about this. So minus 14 over 9 and then minus 65, because I'm adding the R3 to minus 14 over 9 R2. So if I do that, if I go on to the next line, the next page here, folks, I can just do it for you. Okay. So remember where we are now here. So I have 1, minus 4, minus 2, 21. I've got 0, 9, 6, and minus 39. And the last one now I've got a 0, 0. This entry here, guys, is, as I said to you, is minus 14 over 9 by 6 plus 5. So if you do that there, you get minus, there's a 3 here, there's a 2 here. So it's minus 14 over 3 by 2 plus 5. Isn't that correct? So I cancel the 3's. So that is minus 28 over 3, I think. Plus 5 is 15 over 3, I think. And I get minus 13 over 3 here, I think. So you get minus 13 over 3 in that position there. This entry here, it's not a 0, sorry. This entry here is, what is it? It's minus 14 over 9 by minus 39 minus 65. God, oh dear God, wherever that is. I think when you do that, folks, when you do the calculation, you get minus 13 over 3 here again. When you do that calculation, I'm just losing the will to live here, but that's what you do. So finally, now, guys, if you look at the step situation here, I've got zeros everywhere, and now once you've got zeros underneath the step, you can back substitute. And when you back substitute here, now in this case, if you look at the last row here, and this is step 3 now here. If you look at the last row here, I've got minus 13 over 3z is equal to minus 13 over 3. So therefore z is equal to 1, which is nice, I suppose. Then you'll see on the second row here, I've got, can I come over here? This is 4. I've got 9y plus 6z is 1 is equal to minus 39. So 9y then is, when I bring the 6 over here, I get minus 45, I think. So therefore then, y is equal to minus 5. Beautiful. And then finally, guys, right at the top there, you get x minus 4 by minus 5 minus 2 by 1 is equal to 21. And when you do that calculation, I got x equal to 3. That's Gaussian elimination. There's no way this is any way. I'm embarrassed. I'm embarrassed for the world of mathematics that you have to endure this. And you have to do this because you will see it being done elsewhere. It's a very popular technique for some reason. And I don't know if when I was your age and when I was going through college and I was doing things that I felt were really, really not nice, I felt it was always my fault. Maybe I'm just not appreciating the beauty of this, or not appreciating the intelligence of what we're doing, that I'm the problem. Sometimes, folks, you're not the problem. It's the thing that's being taught is the problem. This is a problem, Gaussian elimination. It's just a piece of crap. But there you are. Everybody in college, in the whole world, does Gaussian elimination. So here it is, my gift from me to you. All right. So there you are. That's the crappy bit. Now what I want to do, if I'm still recording, is I want to do the clever thing. This is amazing. You're going to be okay. This is the contrast here is just going to blow your minds. You're probably looking at this maybe Sunday evening at 8:30, and you're just going to be. This is going to rock your mathematical world. The next thing, because it's just so clever. There's just no way I would have thought of this. What we're going to do next. It's just, and it involves, I suppose, what's called machine learning. So now we're going to use machine learning to solve simultaneous equations. A very simple kind of demonstration of machine learning. And machine learning basically is the machine learns as it does a calculation. As it does a calculation, it learns to be better. So it does one calculation, it gets an answer, and then it uses that answer to improve the answer, and eventually gets to the right answer. That's what I suppose that's one definition, very simple definition of what machine learning is. So the first thing that you do is what's called the training part, and then once you've trained it, it gets better and better and better at what you do, and then eventually it does the calculation for you without seemingly by itself, without you set it in place, you push it off the hill. It's like a marble on the hill and it rolls down the hill. This is just great. All right, enough bullshit. Let me just show you what it is. Okay. Now, these are called, the things we're going to do now are called iterative techniques. Now, if these days, folks, everybody's into artificial intelligence and machine learning, and I'm going to do this. I'm going to jump on the bandwagon here. You're going to be, unfortunately, things like machine learning and artificial intelligence, they sound like really wonderful, but at the root of them all these techniques is a basic mathematical technique that that you're going to see now in operation, and you think, that's it? That's all it is? It's like relationships, folks. Really, relationships are built up to being this great, wonderful thing, but they're not that great. Actually, you're better off playing squash. Just squash is better with a better use of your time. All right, but let's talk about machine learning now. The iterative, is that how you spell iterative? Is there an I or an E? I don't know. I can't spell anymore. It's been cooped out in the house with my children. I've lost all will to do things properly now. But let me just show you. Let me just start this, and we will finish it tomorrow. Okay. So let me just show you the example that's in the book. I'm just turning pages here. Stay with me. Don't go away. Yeah. Now, there are two techniques that we're going to be using. There's one called Jacobi's method. That's the first thing we're going to be doing. And the second one then is what's called the Gauss-Seidel method. Now, Jacobi is a guy who obviously came up with the first technique. It's really clever, actually. And the second one's actually very, very clever as well, probably invented by Seidel, who then attached the name Gauss to it in order to kind of improve its marketability in mathematics. It's pathetic, but that's what people do. Okay, so let me just show you what the basic problem is and the basic setup is. So here's what you might be asked to do in the exam. Let's do Jacobi's method first. All right. Now, we need to tell the machine or the computer how to improve its answer. So really, the machine learning is not machine learning at all, really. It's just the machine is doing what we're telling it to do. So you need to tell the machine how to improve its answer. Now, we don't know before we begin that this is going to work. That's the amazing thing. That's the you just try. You hope that this is the triumph of hope. So you hope that this is going to work. You don't know before you begin that it is going to work. Okay, but Jacobi has found that if you do this, it does work. And this is the clever thing, folks. Okay, so the very first thing you do, now this is really, really important, is you take the first equation. So here's here's the first thing you do. So here's, can I call it step one? Is you write from the first equation, 2x plus y is equal to 4, you write x in terms of y. That's what you do. First equation, write x in terms of y. And using second equation, write y in terms of x. So this is the important idea. This is the important component of the recipe. You go to the first equation, you write x in terms of y. You go to the second equation and you write y in terms of x. And you may ask, Jerry, why are we doing this? Because this is what works. Okay, so let's do this. Can we just do this? And we'll just set this in motion for a bit, and then we might stop then. So let me just go back to the equations. You've got 2x plus y is equal to 4. That's the first equation. So if I write x in terms of y here, I get 2x is equal to 4 minus y. I think you agree with that. I subtract y from both sides. We divide both sides by 2 now. Therefore, I get x is equal to 2 minus a half y. Let's call the half y 0.5y. All right. So that's the first thing I've done. So this is 1a. I've written x in terms of y. 1b then is I write y in terms of x using the second equation. So I get x minus 3y is equal to minus 5. So therefore, minus 3y is equal to minus 5 minus x, subtracting x from both sides. Multiplying both sides by minus 1, then I get 3y is equal to 5 plus x. And so therefore, then y is 5 over 3 plus 5 over 3x. Boom, boom. And now, as it stands, I haven't done anything. All I've done is I've taken the first two equations and I've rewritten them in a specific way. From the first equation, I've got x in terms of y, and in the second equation, I got y in terms of x. No, that's not right, because this is 1. Isn't that right? Because this is x. When I divide both sides by 3, I get 1 over 3. Sorry. So I get 5 over 3 plus 1 over 3x. I think I'm good now. Okay. Now, here's the clever thing. Here's the magic. Now, I'm going to modify these two formulas in a certain specific way. So this is step 2, and let me do step 2 here. And what I'm going to do, folks, is I'm going to call, so basically what we want to do is we want to start with a value, we want to guess a solution for x and y, and then use the computer or your calculator to get a better solution for x and y. So let's call let's call the old values, whatever values were the current values. Oh yeah, let's say call it current, actually, rather than old. Let's call the current values for x and y xn, yn, because I'm just crazy. Okay, I'm calling them x and y. You can call them whatever you like. Okay. Call new values for x and y. Now, I don't know what you would suspect here, what the notation should be. But if these are the values for x and yn, the old values or the current values, let's call the new values xn plus 1 and yn plus 1. Okay, and the reason why it's plus 1 and plus 1 is because this is the next step in your calculations or in your machine learning. So this is the current values for x and y. These are your new improved values for x and y, or you hope that they're improved. And because this is you're using these values here, are the x and yn to get your xn plus 1, that's the reason why it's plus 1 and plus 1. Okay, but really, folks, you can call them anything you like, but let's go with this notation here. Okay, so these are your current values for x and y. These are what you hope are your improved values for x and y after doing one calculation. And that's the reason why it's plus 1 plus 1. You're doing one calculation on the x ends and the y ends. So that's step 2. And here's step 3, folks. And I want to do it, well, can I do it here? And I'll put it on the next page. Here's step 3. Now, you go back to your formula for x in terms of y. And what you do here on the left-hand side is you write xn plus 1. And on the right-hand side, you replace the y by yn. Okay, so this is step 3. On the left-hand side, you have your new values for x. And on the right-hand side, you have your old values for y. Down here, you've got the new value for y on the left-hand side. And on the old value here, on the right-hand side, you have your old value for x. And the solution of your simultaneous equations that we've got here, this and this, form the basis of what's called your iterative scheme. So where do these forms come from? They come from the simultaneous equations themselves. Why am I writing xn plus 1 on the left-hand side and yn on the right-hand side? Because Jacobi found this works. Now, guys, this is there's no way I would have come up with this. This is just so smart. This is just like, why are you doing this? It's like hope. You're hoping that this works. You don't know if it will work before you start doing it, but you hope that it does. Okay, so this is very, very kind of positive mathematics, really. Similarly here, where does this yn plus 1 and xn formula come from? It comes from the second equation. I've written y in terms of x from the second equation. And on the left-hand side now, I write yn plus 1. And on the right-hand side, I write xn. So what you're doing here, if you look at the first equation here, I'm using the old value for y to get the new value for x. Here I'm using the old value for x to get the new value for y. So this is what's called the basis of your iterative scheme. So here's at the end of step 3, here's what you have. In this case, you've got xn plus 1 is 2 minus a half yn, and you've got yn plus 1 is 5 over 3 plus a half plus a third xn. That's what you get. So how do you proceed? Now here's the next thing, is you guess a solution. So the first thing, the first guess that you come up with, you're going to call x naught, y naught. So let's guess, traditionally you start off with 0, 0 or 1, 1 or something like that, 2, 2, whatever. It's up to you, but usually you guess x0 is equal to 0 and y0 is equal to 0. You guess. So the first iteration, you're guessing that your value for x is 0 and your value for y is 0. And then what you do, folks, is you use this formula here to get your new value for x and your new value for y. So let's call the first value your improved value for x, your first improved value for x, let's call that x1. And if you use this formula here, folks, you see it's 2 minus a half y0. And look, if n is 0 here, so basically what I'm doing here is I'm putting n equal to 0 in my general formula up here. And up here, to get y1, I get 5 over 3 plus 1 over 3 x naught. So again, I'm putting n equal to 0 in my general formula up here. I'm putting n equal to 0 in my general formula here. Okay? Or another way to think of it, folks, is this formula here tells you to get the new value for x, use your old value for y, new value for y, get your old value for x. And then you substitute in here, guys. So x1, therefore, x1 is 2 minus a half by 0, which is 2. Agreed? And then y1 is 5 over 3 plus 1 over 3 by 0, which is 5 over 3. So you've started off with 0, 0. And after one iteration of the method, you get x1 is equal to 2, and you get y1 equal to 5 over 3. All right? You continue. Now, the question then is, when do you stop? Well, you stop when you start seeing what's called convergence, and we'll talk about that the next time. But let me just go on and just do a couple more. Now, I will tell you in the exam, this is one step of the iteration. I will tell you in the exam maybe to stop after 3 or 4 or 2, 3 or 4 steps. But here's just one step. So let's look at another step. If I can actually change the page, I can, because I am just so clever. So talented. So now let's look at second iteration. Now this is x1 and y1. So now I want to get x2. x2, if I go back to my formula here, x2 is equal to 2 minus a half y1. And y2 is 5 over 3 plus 1 over 3 x1. So what I've done here, folks, is gone to my general formula and we replaced n by 1. Or basically what I'm doing is going to my general formula and I'm saying this is my new value for x is 2 minus a half my old value for y. And my new value for y here is 5 over 3 plus 1 over 3, the old value for x. Now, in this case, I get 2 minus a half by y1 is 5 over 3. And in this case, folks, you get 5 over 3 plus 1 over 3 x1, and x1 is 2. Now be careful here. Be careful here because my x1 is 2 and my y1 is 5 over 3. And in this iterative scheme, to get your new value for x, you use your old value for y. And to get the new value for y, you use your old value for x. So be a little bit careful here, right? And that's what I've done here. So I've done that. So can I come down here? I'm sorry to do this to you. So that's 2 minus 5 over 6. And that's, this is 12 over 6. Isn't that right? So you get 7 over 6. And then for y2, can I come down here? Again, sorry to do this. You get 5 over 3 plus 2 over 3, which is 7 over 3. So after 2 iterations, you get 7 over 6, and you get 7 over 3. Okay? And let's stop after, let's just do 3 iterations. Let's get x3 and y3, and then we'll stop. And we'll continue this next time. Then x3, 2 y2, which in this case is 2 minus a half by 7 over 3, because that's what the value for y is here, y2. So that's 2 minus 7 over 6. Which is 12 over 6 minus, which I think, folks, is 5 over 6. That's your value for x3. And then your value for y3 is it's 5 over 3 plus 1 over 3 x2, which is 5 over 3 plus 1 over 3 by x2. Guys, we got x2 was 7 over 6. So you get 5 over 3 plus 7 over 18, I think. And so that's, I think that the common denominator here is, so that's 30 over 18 plus 7 over 18. And you get 37 over 18. Now, I've done it in terms of fractions. You can do it in terms of decimals if you want. I will tell you how many decimal places to work to in the exam. But that's basically what I want you to be able to do. I want you to be able to use these kind of iterative schemes in order to get a solution. Now, we will see next day how actually this gets better and better. The more steps that you do, the closer you get to the actual answer. But for the moment, just want to leave this festering in your brains over the weekend, this idea of using old values for x and y to get new values for x and y. This is called an iterative scheme. You can maybe call it a fancy way of calling it machine learning, because basically what you're doing is the machine is learning how to get a better solution. It's using its old information to get a better guess as to what the solution is. So the machine is learning as it's going along. That's just kind of nonsense, really. What you need to be able to do for the exam is get this kind of stuff into your brain, and you need to start practicing this. Okay, guys, I'm going to stop here, and we're going to continue this stuff on next week. Have a great weekend. Don't touch each other because you're going to make each other sick. And yeah, have a good weekend. Get out, get some fresh air. Be nice to your parents and your siblings. And talk to you next week. Okay, guys. Thank you. Bye-bye.